Student, today we will do force between multiple charges. Multiple charges means there are many number of charges. Q1, Q2, Q3, Q4, Q5, up to Q1 it may be there. So what is total force on Q1? We have to calculate. We know total force on charge Q1, Q2 given by Coulomb's law. It is given by F12 equal to 1 by 4 pi epsilon naught Q1, Q2 by R12 square into R12 cap, if you consider direction. So first it is superposition principle. First superposition principle, according to superposition principle, the force on any charge due to a number of other charges is the vector sum of all the forces on that charge due to the other charges are unaffected due to the presence of the other charges. First, suppose we consider three charges Q1, Q2 and Q3. So let's consider Q1, this position, this is from origin a distance of R1. Q2 is a distance of R2 and Q3 is a distance of R3. First, we have to calculate force between Q1 and Q2. Q1 and Q2 will give this direction R12. So force will be this way, F12, and force F12 will be according to Coulomb's law, F12 equal to 1 by 4 pi epsilon naught Q1 Q2 by R12 square R12 cap. Okay, R12 square R12 cap, it means we given the vector sum. Okay, and for Q3 and Q1 force is given by, first distance is given by R13 this way, and this will be the F13 vector. So F13 equal to 1 by 4 pi epsilon naught Q1 Q3 by R13 square R13 vector. Now what is the net force between F12 and F13? We have this vector vector. So we have to use Pythagoras theorem. Sorry, vector addition theorem. Vector addition theorem. This way. This way. This will be the force vector, F vector, and F is the your summation of F12 plus F13. This will be equal to 1 by 4 pi epsilon naught. This Q1 will come Q2 by R12 square R12 cap plus Q1 is taken common, Q3 by R13 square R13 cap. This is the force on charge Q1 due to presence of Q2 and Q3. Okay, now there are many charges, there are 5 number of charges, then your diagram will be, this diagram is something different. So first, let us draw the diagram. First diagram, this is suppose Q1, a distance of R1 from origin, Q2, distance of Q2, distance of R2, Q3, distance of R3, Q4, distance of R4, and so this is Q5, Q5 a distance of R5. This is the distribution of 5 number of charges. It may be n number of charges. So first you have to find out the force between Q1 and Q2. Same way, the force distance is given by R12. It will direction this way. This will be F12. Q1, Q3. This will be R13, F13 vector. Just we have extended the diagram. First Q1, Q2 we extend upward, and Q3, Q1 we extend this side. So resultant with F1 to F13 given by this will give F1, 2, 3. Okay, resultant force between F1 and F2. Next, our 4 will come. Q4, this one, Q4 and F1, 2, 3. What is the resultant force? First, the force between Q4 and F1, 2, 3 we have to calculate. First this way, same way you can draw the diagram. Wait, you can find out the force between Q4 and Q3. You can find out that this force between Q4 and the resultant. Just a minute. First Q4 and Q1, the direction is this way. R41. So vector will be given by this way, F14. The resultant of F123 and F14 is given by this expression. This will be the resultant. So this is F1, 2, 3, 4. Now lastly, the Q5. Our Q5 is this one. The Q5 and Q1 is given by this expression. R15. And result, this will be this side. F15. So final result will be this F1, 2, 3, 4 plus F15. This will draw this way, and final result will be this F. So F is the vector sum of F12, F13, F14 and F15. The total force is the vector sum of the individual forces. Now individual forces, we can write down the value. So it will be 1 by 4 pi epsilon naught. Q1 we can take common. Q2 by R12 cap plus Q3 by R13 cap plus Q4 R14 cap plus Q5 by R15 cap. If there are n number of charges, Then you have to extend this R5 up to Rn. Okay. This is the principle of superposition.